Hello, thanks for clicking on my video. If you like my videos, if you find them useful, please subscribe. Also, please leave me comments on what you want me to cover. In the meantime, let's get started right now. So last time, or a couple of times ago, I covered the NumPy library. Today, we're going to cover Pandas library, which builds on NumPy, but it's actually a whole different purpose. It's all about data cleaning, data exploration, data manipulation, and doing all kinds of function on data. It is hugely popular with machine learning. People use all Pandas library with Python all the time for working with data. All right, so let's get going with the code. First few lines are just so we have, let me move my face around so you can see the code. First few lines is just so we have an image of pandas so you can see. Actually, it's kind of cutting it off. That's weird. Anyway, it doesn't matter. It's the symbol of pandas. Not so important right now. Let's install pandas with the pip command. We will do that. And it's already installed. I think it's part of the container that you get from Google Colab, which is equivalent of Jupyter. I used to use Jupyter Notebook. Now it's Colab is same functionality as that. It's SaaS-based, nothing I have to install on my computer, so I just switched to Colab for now. Let's import pandas as PD. The name will be PD whenever we refer to Panda. Let's make life easier. So now we're going to call a constructor so that we get a variable called df that's a data frame. Now, data frame, just think of as a CSV file or an Excel sheet with the labels on the top, right? If you think it like that, that makes everything else makes more sense, right? But because the data can come from various different sources in different formats, as soon as you bring it into the Panda data frame format, then anything the Panda has to offer, we can use on that data set. So that's the gate, if you will, right? So any data coming in should be converted to a data frame so we can get going. All right, so I don't know if I clicked on that, so let me make sure that's done. First example, we're going to make a list, and we're going to use that list to convert to a data frame so you can do all the Panda business that I want to show you. So let's make a quick list of a bunch of characters. I'm going to convert that with this command, pd.dataframe, into a data frame. And the name of the data frame in this particular case, the variable is df, so you're going to refer to that. If I run df, it tells me what the data frame looks like, and it's pretty, actually, visually it's pretty clear. You have the index that comes by default, and you have this tabular data. In this case, happens to be just one column, but A, B, C, D, E, F, one column of data. Very simple. Now, Panda comes with many functions that we can use. One of them is describe. It gives you really good overview of the data. So if I run that, you will see it's telling me there are 6 counts. All of them are unique. Top equals A. I think that means the first one. I'm not sure. Frequency is 1. That means A occurs once. And if we use bigger data set, you will see this become even more useful because it will give you the same parameters on each column/features. All right. We don't have this problem in this particular data set, but sometimes when you have data sets, there are null values. You may want to drop them in case your mathematical calculation that you're going to do down the road doesn't run into problems. So we're going to run that just to show you that's possible, but that's not the case in this particular data set. All right, second example, we're going to use sklearn and we're going to import Iris Dataset. Iris Dataset, if you remember from previous videos, some scientists some time ago put together a tabular data about different flowers, and based on its variables, he or she figured out what the flower should be. That's the dataset. It's automatically available through Iris. So we're going to run that. We're going to load this particular library, if you will, and then we're going to load the Iris dataset into a data frame. Again, you see how the data is coming in. We're going to convert it into a data frame so that we can do the functions down the road. So now we have the Iris dataset in a variable in the data frame format called iris_df. Now that we have that, we run describe like we did above, and you see for each column /features/variables, it gives me the mean, the standard deviation, minimum, and so on and so forth. You get a good summary of the data without having to look at the whole data set. All right, now sometimes you want to see what the column headings are, right? So you can actually work on them. So if we run this particular function called columns and then convert into a list, you see a list of columns that looks like that, because those are the headings in the data set. Easy enough. Now what we're going to do, we're going to add another column called target, because target is what's going to be the classification in the end, right? We did that. Now if we do column headers, and this one didn't work for me, I'm not sure why. I still don't see the target. Oh, there it is. There it is. Target has been added as another column at the end of the data set, of the data frame. All right, now they've done that. If we just run head, just like a Unix command, it gives us the first 5 instead of 10 of the rows of the data, and you see them right there. So you see how you're visualizing the data with Panda, and this is just the beginning. The Panda is just superbly powerful. Third example, what we're going to do is we're going to create another data set, because this data set is more, it's easier to show you what I want to show you down the road. So we create a variable called data. It has a two-dimensional data set, has name, age, and city at the top, and it has some variables and some rows. I think maybe 4 rows. Simple enough. Again, we're going to convert that into a data frame, and I've used rename. I use the same name df, but in this case it doesn't matter because we're not going to go back and use the other data we had before. Okay, so let's do that, and then now what we're going to do is we're going to actually set an index. Right now, this data set doesn't have an index; it's just like a CSV file, right? We're going to set an index. We're going to say, hey, the index column for this particular data frame is the column that has the title name. It's called label, that has the label name, right? So we just set that. Now that we have a label to work with, we can do other functions. For example, we can say, hey, if the label equals Alice, give me that particular row. So we do that, and we get that row that has Alice's data. All right. It has age and city, and it also gives you some metadata about the data itself. Now, we can also do the same thing to select multiple rows from the data. In this case, we're selecting Alice and Charlie, and there they are. And notice that we're using a function called loc, L-O-C. This function is used many times in using Panda to get the particular data that you want out of a big data set. By the way, Panda can handle humongous size of data sets. So we do that. Now again, we're doing the same function. This time we're going to actually get only one column from this particular row, and we're going to say get me the age of Alice, right? Age happens to be a column in the data frame. Now we can do the same thing, and we can use the same function, but this time we want more than just one row and more than one column. Basically, you're doing a search operation on the index, kind of like in the ELK stack. All right, now we're going to actually use a condition versus just matching, right? To get the different rows. In this case, if the age is less than 35, give me those rows, and it happens to be 2 rows. Okay, there's another function called iloc, I-L-O-C. This one is actually based on integer index. So you can say, give me the first row, give me the 10th row, so on and so forth. Now you're not matching, you're not doing an if then else, you are doing looking for a particular numbered rows or columns. So we run that, and give me the first row because I put 0 as the index. We can also drop a particular column or a row. In this case, we set the axis to be 1, that means vertical, and we're going to drop the column age from this data frame. We just did that. Now, if I run the same query that we ran before, we want to get the age of Alice. We can no longer do that because age is now gone. And by the way, in place means don't create another variable, change the variable the data frame that you already had. So the age data is now gone from the data set. Of course, you have to be careful with that. So I run that, I look for age, it doesn't work because age doesn't exist. So you get a taste of how powerful Panda is because it has so many built-in functions that you can use. They also work on huge data sets. So I hope you found this video useful. If you did, please like and subscribe and leave comments about what else you want me to cover, or if you have any feedback. I will see you next time.